Hello, and welcome to this presentation, Understanding Insulation Resistance Testing. In this presentation, we'll explain what electrical insulation testing is, why it's important, and how insulation resistance is measured using megohmmeters or meggers. Resistance with units of ohms is usually measured using an ohm meter or an analog or digital multimeter. This is done by applying a small DC voltage across the resistance and then measuring the resulting current. Ohm's law can be used to calculate the resistance. It's important to note that the maximum resistance that can be measured by most meters is on the order of tens of megohms. This is limited by the maximum voltage that the meter can create between the test leads. A very high resistance also requires a very high voltage in order to create a current that's large enough to be accurately measured. For most resistor measurements, a standard meter is sufficient, but these meters cannot be used to measure the resistance of many common insulators, with resistance values in the tens, hundreds, or even thousands of megohms. The word insulation is commonly used to describe materials that provide protection from unwanted, unexpected, and/or damaging electrical voltages and currents. Depending on the magnitudes of the voltages and currents present, insulation typically has a resistance of megohms, although for some applications, this insulation resistance may even be in the giga or teraohm range. Insulation can, however, lose its effectiveness or be degraded by a wide variety of factors, including material aging, temperature, exposure to moisture or chemicals, physical or mechanical damage, very high voltages, etc. This effectiveness may decrease gradually over longer periods of time, or may occur suddenly. And failure of insulation can lead to many different types of problems. For example, the most common reason why induction motors fail is due to degraded or faulty insulation in their windings. It's therefore important to be able to verify or measure the integrity of insulation in many different applications. As mentioned a moment ago, motor winding insulation quality is very important. Many cables need appropriate insulation between conductors and between the conductors and the outer cable sheath. And there are many types of enclosures or shields whose purpose is to protect human beings from dangerous voltages and currents. In addition to troubleshooting, insulation testing is also often performed as part of a preventative maintenance plan, since a decline in insulation resistance over time can provide advance warning of potential device failure. Also, in some parts of the world, insulation resistance testing is required for many consumer devices. But as we mentioned earlier, very high voltages are needed to measure very small currents, and in the case of insulation, these voltages are usually much higher than those which a typical multimeter can provide. For this reason, insulation resistance is tested using special insulation resistance testers or megohmmeters. You may hear these referred to as meggers, after the name of a well-known manufacturer of these devices. In fact, the word megger or meg is sometimes even used as a verb. For example, megging a motor. One important thing to know about insulation resistance tests is that they must always be performed on de-energized circuits. One thing that all insulation resistance testers have in common is they can generate and apply very high DC voltages. DC is used in all insulation testing, even if the device under test normally operates on AC, as in the case of a motor. Note too that some megohmmeters can also function as normal, lower voltage meters. And one final thing to be aware of is that any comparison insulation tests should always be performed under the same or similar conditions of temperature and humidity, as both of these can significantly affect measured insulation resistance. Let's pause for a moment to talk about safety. Insulation resistance testers can provide very high voltages, often 1000 volts or more, but the currents they create are also usually very low, in the range of milliamps or microamps. Contact with the energized output of an insulation resistance tester can therefore cause a painful shock, similar to that from an electric fence, but generally not a dangerous or lethal shock. That said, proper training and personal protective equipment, such as insulated gloves, are strongly recommended whenever performing insulation resistance tests. Let's get back to voltages. Most insulation resistance testers have a selectable DC voltage, and the selection is usually done stepwise, with common steps being 50, 100, 250, 500, and 1000 volts. In some cases, the voltage needed for a test may be specified in a standard or similar document. But unless specified otherwise, a good rule of thumb is to use a voltage that's about twice the rated voltage. This rule of thumb, however, only applies to voltages up to about 1000 volts. It's also important not to use too high of a voltage in order to avoid damaging the device under test. Insulation resistance testing should be non-destructive. There are many common applications of insulation resistance testing. These include testing of resistive heating elements, different types of cables, single and three-phase motors, HVAC compressors, transformers, and various components of electric vehicles. Over the next few minutes, we'll talk in slightly more detail about a few of these applications. We'll start with a very simple example of testing a heating element. Note that for most heating elements, the orientation of the terminals, hot and neutral, is unimportant. The test voltage should be set appropriately using the 2 times rule that we mentioned earlier. For example, an element designed to work with 120 volts AC should be tested with a voltage of 250 volts. If we first measure between the 2 terminals, we should see a small resistance, maybe tens of ohms. But the resistance between a terminal and the outside of the element or coil should be very high, megohms or greater, when tested using an insulation resistance tester. A more common but also more complex application is testing cables. This is particularly important for cables that are used to carry high voltages, such as in electric vehicles. After isolating the cable, insulation resistance is normally tested between each pair of conductors. This test can also be performed between a conductor and the outer cable sheath, shield, or ground. Another way of testing cable insulation is to test between the outer insulator and all conductors together. In this case, one test lead or clamp is connected to all of the conductors simultaneously before running the insulation resistance test. Another common but even more complex insulation resistance test is measuring the insulation resistance of motor windings. Often testing is performed both between each individual winding and the chassis or ground, as shown here, as well as between pairs of windings. As with other insulation resistance testing, the motor must be separated from power. Note too that in order to test resistance between a winding and ground, a suitable ground point on the motor housing must be identified. It may be necessary to sand or scrape to remove some paint to get a good motor chassis ground connection. The connection to the windings may be made in various ways. For example, the 2 non-tested coils in a 3-phase motor may or may not be connected together or connected to ground. Regardless of how the test is run, the measured insulation resistance of the phases should be both high and roughly equal. A typical insulation resistance test lasts from tens of seconds to tens of minutes. It's normal for measured current to change over time because the overall current consists of different components, such as the charging current and absorption current, and these have time-varying values. Ideally, total current will decrease during the test, and thus the reported insulation resistance will increase over time. On the other hand, if the current through the insulation is increasing, this will manifest itself as a decrease in resistance over time, which usually points to serious issues with the insulation. There are 2 standard methods for quantifying this change in insulation resistance over time, namely polarization index and dielectric absorption ratio. Let's look at each of these in a bit more detail. Polarization index, or PI, is the ratio of the insulation resistance measured after 10 minutes to the resistance measured after 1 minute. Dielectric absorption ratio, or DAR, is the ratio of a measurement made at 60 seconds to one made at 30 seconds. As can be seen on the right, these measurements have different scales with regards to what is good or bad, but in both cases a value of 1 or less is bad/dangerous, because this means that the insulation resistance is decreasing over time. Although there are different standard ranges, in general a PI of greater than 3 or a DAR of greater than 1.6 is considered a good value. Of these two measurements, polarization index is a more common and a more comprehensive test since it measures over a longer period of time. But clearly this also increases the time needed to run a test. Note too that since these values are ratios, they're generally unaffected by temperature and humidity. PI and DAR can be measured and calculated by hand, but many insulation resistance testers have one-button support for running these tests and displaying the results. Let's end with a brief summary. Insulation refers to materials which prevent, or rather limit, the undesired or unexpected flow of current. Standard ohmmeters and DMMs generally can only measure resistance up to the low megohm range. Therefore, special megohmmeters are required for performing insulation resistance tests. These are also often referred to as meggers. These tests are able to measure resistances into the high megohm, gigaohm, and even teraohm range, and they do this by applying a test voltage in the range of hundreds or even thousands of volts. This kind of testing is most commonly performed on cables, motor windings, transformers, etc. Generally speaking, the measured value of insulation resistance will increase over the duration of a test, since the flow of current through an insulator usually begins at a higher value, but decreases over periods of seconds or minutes. Note that if insulation resistance decreases, this often points to potentially serious issues. And finally, we briefly discussed polarization index and dielectric absorption ratio, which are both used to numerically quantify this change in insulation resistance during the measurement time. This concludes our presentation, Understanding Insulation Resistance Testing. If you'd like to learn more about electrical testing, power testing, or test and measurement instruments from Rohde & Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.